with all the programming world, and that's why since then I have been a bit in between research, science, programming, free and open source software, and all these communities. I'll just type my email address in case you ever want to reach out. But I'm also easy to Google. Oh, sorry, I meant to make this a comment. So we will start with Bash. So Bash is, what is Bash? It's the most popular and the most widespread shell, which brings the question, what is shell? So shell is a program that lets you interact with the computer at a lower level than maybe you're used to. So the shell, you can also refer to it as the command line interface, as opposed to the graphical interface, the GUI, which would be, so I don't do this very often, but if you want to open files, you know, or create files, you know, you could you would double click this. And instead, we're going to do this not using a mouse that lets us click, but we're going to use the command line right now. And you will see that in an HPC context, it is necessary anyway. Like here, it's like I have the choice. I can either create a directory here, you know, on my desktop, and then remove it, or I could do it graphically using my mouse. But on the HPC cluster, you will have no choice. You will have to be using the command line interface. What else did I want to tell you? Yeah, so like maybe on your mobile devices, you use a touch screen, which is yet another way of interacting with the computer. And just as a reminder that, you know, your smartphones are computers. Maybe we forget about this. Okay, so you probably, if you're here, it means that you have a motivation, you have a use for high performance computing. So HPC stands for high performance computing. And clusters are one way to achieve high performance computing. So I don't know, maybe you work in genomics and you receive really large data files. Maybe they're so large that you cannot even open them on your laptop. So that brings us to, you know, we need more computing resources. Or maybe you're running physical models or statistical models, and maybe you can kind of run them on your computer, but it's really slow, it takes forever. Maybe you want to parallelize, and maybe in a very small way you can parallelize on your laptop because you have more than one CPU, but on the cluster you have way, way more. You have many more CPUs, more speed, more memory, called RAM, or more storage, called disk, etc., etc. So yeah, I'll just mention a use case because you will see that throughout the lesson. We'll come back to it. Yeah, let's imagine I'm doing research, so I'm collecting data. I have several data files, and I need to grab like the second line. Maybe the second line of all my files contain a specific value. I don't know, maybe I'm monitoring for the room temperature, and I want to make sure that this room temperature is staying more or less constant. So if I have 1,000 files, do you really think that I can click every file one after the other, copy, paste, and put this value in another file? Well, first of all, it would take forever, and also you would probably introduce mistakes because you would forget one file, etc. And maybe you have even more than 1,000 files. Maybe you have 10,000, 100,000, etc., etc. So we're going to let the shell do this for us, and that's why we're learning basic and advanced commands with so you will hear me saying bash or the shell or the CLI quite indifferently, right? So I just mean the same thing. So I invite you to open a terminal, just like I did. I don't know which OSs you're running, but soon enough we will connect to the HPC cluster of the university, so we will have a similar experience anyway. So I expect you to have like an open terminal and type along with me. So we're doing interactive teaching and learning. So we'll review very basic commands quickly. So you probably know of LS already, right? That lists the files and folders where you're currently at. Where you're currently at is obtained by running pwd, which stands for Print Working Directory. So we are in our home. So I guess in your case you will not have home Marianne, but something else with your own username. And your username, by the way, you can obtain by running who am I, so plain English. If this is not working for someone, please raise your hand and Alberto will come to you and help you out. Maybe I'll just leave the keyboard for 1 second just to mention REPL. I think that's also interesting for your computing culture in general. So REPL stands for Read, Evaluate, Print Loop. So this is this way of interacting with the computer where, so when I type a command and then I press enter, what happens is that the computer reads this input, so it's waiting for input as this indicates near the prompt being this $sign, and you will see on the cluster we will see this $sign as well. So that's the R, read, evaluate, so run, execute, and print, as you can see, it returns an output, and loop means that it comes back to waiting for the next input. So anyway, this notion is good to be aware of. I guess you know CD for change directories. So I could go into my desktop. So I could look at the things over here. Do you know of the A flag, like this? So that lists everything we already have with ls plus those things starting with a dot, which are sometimes called hidden files or hidden directories. Actually, if I go just back into my home, so I'll give the absolute path for it, and I run ls flag A, then I have, as you see, a bunch of dot files. You probably have different ones. They usually correspond to configuration information. Yeah, I was going to talk about the root, but maybe we'll do this over at the cluster where we know we all have Unix systems, because maybe right now some of you have Windows PCs, so the Unix case would not apply. Yeah, so I think we don't need to wait. And I would say we can connect already to the cluster. So I'll just clear my screen. So for this, we use a command called SSH, which stands for Secure Shell. So our terminal will be connected to a remote computer, in our case, the cluster of the University of Trento. So here you type SSH, this command, your own username with the HPC cluster. I don't know which one it is for every one of you, obviously. And hpc2.unitn.it. Oh, sorry, I'm not online. I'm not connected to the network. Should I use this one? Or a wired one, even? I don't know if yeah, when I was home, I would use the Pulse Secure program to open a VPN and be able to access this network. Over here, we're already on the University of Trento network, so it shouldn't be useful. But are you all able to log into the cluster? Okay. If it's the first time ever you're doing, you're probably getting this information message with where you have to confirm that you want to go there, and you type yes. Oh yeah, sure. Connect. What is an offer connect? Thank you. So here I type in your password. And here I am. So as you can see, the preamble here has changed. And if I really want to double check, I can run the appropriate commands. So host name. I'm not on the same, oh, maybe I don't remember if I ran it before. So actually, let's leave another terminal open. Let's open another terminal that will remain connected to the local machine. So here, that's my home on my laptop. I can print the working directory, check who am I. Marianne, that's my username on my local workstation, my laptop. Whereas here, if I type who am I have a different username, and why not? I don't always. You either get to choose it if you're setting up your own laptop, or you get given one if it's with the administration of the university. And yeah, so host name, I was just comparing the host name here. So we are on the HPC cluster, whereas over here, I don't know if I have the same font size. Yeah, host name. Here, MK Core is like the name I gave to my domain here. Yeah, if you didn't want to really go onto the cluster, but just like connect to it and see, for example, what's in your home, you could run the same SSH command. Over here, HPC2. Do it with your own username, obviously, again, UniTN. And pass a command like this between quotes. So you need to ensure it's you. And then, so actually, I've run like ls on my home over there. And indeed, if I type ls, that's what I get here. And another quick thing I wanted to show was about like copying files, even though that's like also a long, like a longer, bigger consideration. But as an introduction, you may want to be aware of SCP, secure copy. So let's say I have this test.txt file over there. I think it doesn't really contain anything interesting. So if I want to copy it over here, I'll go, so here I'm local, right? And over there I am remote, again. So SCP, I'll type username at the cluster domain. And here the syntax, so tilde is a shortcut for my home, so your home in your case, test.txt, and the dot is the current working directory. So I mistyped my password, I'll have to do it again. Okay. And reciprocally, I may be interested in copying a file that I have here locally, remotely, so onto the HPC cluster. So here, there's a text file that my 5-year-old nephew typed, so it doesn't really make any sense here, but I'll type that. So yeah, SCP, and then I'll give the destination here, HPC2. Can you still read, even if it's at the bottom? Yeah. UniTN. So yeah, I'll leave it in my home. Okay. And here now I have this additional text file that I just copied over the network. Yeah, so here in your home, it's probably a good place to store files, to store large files. Well, I'm not like from the Direzione dei Servizi Informativi, quindi So I'm not like the one like giving you specific instructions, but just for your general culture, and then you'll look into the details. You know, the university is doing backups for you, etc. So that's like safer to like keep your data sets for your research. Whereas, for example, if you're running heavy computations, actually maybe you want to do it somewhere else. So that's like something for you to figure out about the cluster, but just like be aware of those things. Sometimes there are like better places for storing and other better places for computing. So we'll just go over how to create, change, modify, and remove or move files. So now that we are on oh yeah, before this, now that we are on the cluster, I know it's a Unix system, so we can all look at the root. So when you notice that when I printed the working directory, yes, welcome, benvenuto. So this, when the path starts with a slash, it's the absolute path. So it's like really like all the paths start at the root here on the Unix system, and you can see that there's a lot of things that you may want to become more or less familiar with at some point. But all the work we're going to do today we will remain in the home. So I could, if I wanted, I could go there. But let me go back to home, and over here I see all the users, probably including you, and I'm going back into my home. And I invite you to do the same thing. Okay, so do you know touch to create a file? I can go like test2.txt. I can display the contents of a text file using cat for concatenate, and it's empty. But if I wanted to printer added, but I didn't ask for anything. If I wanted to add some content, I would use a text editor. So I don't know if you already have a favorite text editor. Mine is Vim. I'm not going to force it on you, but still, I'll show it first. So also because Vim is available, on every system that you will connect to for computing. So, and we'll see throughout other commands that it's useful to know the basics of Vim. Even if you're not going to use it in your day-to-day, it will come in handy throughout other commands that we see. So if I go like vim test2.txt, here I have an empty file, and if I want to type things in it, I have to go into insert mode. So I'll type I, and here I can start typing. And when I'm done typing, I leave the insert mode, so I go escape, and then to save and quit. So when I'm not in insert mode, I start my instructions with a semicolon like this, and I will save with W, it stands for write, and then I can quit with Q. You will see that we'll be quitting things with Q more than once throughout the lesson. So alternatively, you could use Nano, which is what is promoted in the Carpentries materials. So the Carpentries are an organization that teaches computing and data management workshops all over the world. That's how I originally met Raffaello, and I came here last year in November. So anyway, some of the content is heavily inspired from their materials. So I can alternatively use Nano to edit my text file. I find that the light is very low. I don't know if it's bothering only me, but could we, turn on, get a little more light? Maybe not even everything, but every other light. But can you still see the screen? Yeah. Okay, very good. Thank you. And here to exit, so you go like, actually that's convenient because you get this like little manual embedded within the program. You go Control X, and that saves and quits the text editor. Now can check the contents of the second test file. Oh no, maybe I didn't save it then. Okay, I don't use, oh yeah, I didn't add a line, I guess. Let's add a line now. All right, and now I have to confirm that I want to save those modifications. I think otherwise you could go like Control O to write first, and then, yes. Right, so I could also go like, third line. So first I could properly save it with write out, Control O, right, and Control X. Okay. Just as a show of hands, who uses what? Do you guys use Vim? Do you use Emacs? Do you use gedit? Do you okay, now that I have a text file, I can copy it with the cp command. So copy test_2. So the copy I will call test_3.txt. And I can double check that the content of test_3 is the same, right? That's what I expect. You can move a file into another one, which amounts basically to renaming it, right? So if I wanted to rename test3 into test4, I would go mv for move, test3.txt, test4.txt. And now if I list all my files, test3 is gone because it has been moved into test4, and test4 contains the same thing as test3 used to contain. And we can also remove a file using rm. So let's remove test4 and check that it's gone. Yes, indeed. Yeah, I think that's all I wanted to tell you quickly about files. Okay, so let's start manipulating more interesting files, not random text files with only 3 lines. So for that I chose data sets from genomics. So I'm not a bioinformatician, so if people in the room have more background and more context, they're more than welcome to contribute to the description, etc. But for various things that maybe I can detail at the very end of the lecture, I am interested in getting more familiar with those genomics data sets. So we will have a bunch of FASTQ files to process. So they're saved in my home, and normally I gave the permissions. We will discuss permissions tomorrow with Alberto, so don't worry if you're missing a few bits here and there. So that you can read the files that I have in my home. So normally if you, let's clear that screen. Please type, in this case, the same thing as I'm typing. And let's make sure you should be able to read those sequences of DNA like I saved them. Wait. Yes.
You need the Marianne.
Oh yeah, grazie. Okay, let me check first with my relative path. Yeah. Okay, FASTQ. Okay, so the absolute path should be home. Okay, so please run this and double check that basically it works, so that it returns this existing file. If the file doesn't exist, you would get an error. Is it working for everyone? So we've seen that we can display the contents of a text file with the cat command. So let's try this. I think the network is detecting a bunch of printers. When I go arrow up, you've probably noticed that before you get the previous command that we just ran. If I'm a little lazy to go like with the left arrow all the way back to the beginning, I can type Control A and just get to the beginning earlier. Honestly, I don't know all the tricks and tips to optimize my keyboard use, but whatever, you know, even if you forget it, it doesn't matter, but like sometimes those details can improve our lives as scientists. So instead of just listing this file to ensure that it exists, I'll cat the file. Ooh, what's going on? Okay, see? So for a large file, using cat is not the best because you're just like, okay, my screen is full, I don't know where it starts, it's not really helpful. So let me clear my screen again. By the way, for this I'm using Control L. I think you can also use clear. So of course I could use Vim, right? Just because or Nano, you know, I could use my favorite text editor to open this file. So I could go like Vim, and okay, at least I see. I know this is the beginning of my file, so that's already you know, more helpful. But the thing is, you may not always want to open a file that maybe you just generated, you know, from data acquisition or data collection, because maybe the file is really, really large and you don't know. So just opening a file sometimes can, you know, take a lot of time and it's a bit frustrating. So I would encourage you first to for example, check the number of lines in your text file. So you can see, you can do this with the command WC, word count. So same path. Oops, excuse me. Control A, WC. And that gives you, so 3 things. There are 3 counts, the number of new lines. So when you arrive at the end of a line in a text file, the fact that you break the line, that you return with the return key, that's a character for the computer. So technically that counts the number of new lines, but you know, so in practice it kind of amounts to the number of lines. That's the number of words, where by default we consider that words are separated by white spaces, and that's the number of bytes. If you're only interested in the number of lines, then you can pass the L flag like this. Okay, so I see that my text file contains 20,000 lines, which is, you know, it's bigger than 3 lines, but, you know, I'm like, this is reasonable to open it with a text editor. It's not gonna crash my laptop if I'm on my laptop, and you know, on the HPC obviously it will not crash anything, and it will not be too slow to open. But still, maybe just to get a better understanding, I don't want to display the entire file. Maybe I want to display just the first few lines. So to get this, I'll go like head. So this command head. It's very convenient because it just shows you the beginning of your file. And here we can start talking meaning and context and science if we like. So I read this on Wikipedia because, again, I am self-taught in bioinformatics. This is not my background. So if I'm mistaking or anything, please correct me. So by convention, those FASTQ files, they give each sequence 4 lines. So 1, 2, 3, 4. that's going to be one sequence of DNA. The actual sequence, the raw sequence, lives on the second line. So that's like your actual sequence, and maybe you recognize those, it's always those 4 letters, A, C, G, T, from the nucleotide bases. The first line is, so by convention, there's this @ character that introduces an identifier, an ID for my sequence, and it's followed or not, I think this is optional, by some metadata. So, I mean, this, to be honest, I don't know how to interpret, but this is plain English, so apparently the sequence is of length 101. Then on the third line, we have, well, basically a repetition of the first line, but starting with the plus sign, not the @. And then on the fourth line, you have something called a quality score. Okay, let's not worry too much about this. At the end of the lesson, we'll see that that's kind of like the difference between FASTA and FASTQ formats, which are both de facto standards in bioinformatics. So we'll actually write a converter from like the FASTQ format to the FASTA format, because more or less it consists in removing this fourth line, removing the quality score. So already you're thinking, back to this idea of, in many files, large files, I have many sequences, and it's always the fourth line that I want to, in this case, remove. So again, let's not do this manually. It would be a nightmare, but instead bash is our tool to do this. So if you have head, maybe you can guess that there's also tail. And this will show us the last few lines. Where am I? Yeah. So that's the end of my file, this one, srr _1.fastq. You can be more specific in the sense that these commands also have flags. You can specify the exact number of lines that you want to display. It's called n. So if I just want to display the first 4 lines, I'll go -n4. So I know that this is exactly the first the data and the metadata relative to the first sequence in this file. And if I wanted the first 2 sequences, obviously I could go like this. And same for tail. Oh yeah, another useful command would be less. So, so if I'm not ready or willing to just open the file with Vim or Nano or another text editor, I will go less. And this will just like fill the screen like with a screen full. So like it will, unlike cat, that displayed everything and it spit out the entire content and I didn't know where I was. This is only going to fill my screen up to the size of my screen. And if I want to go further, I can press enter. But at least I'm not like overwhelmed with a stream of data. And in there I can use, I think I can use things similar as, the similar commands that we do in Vim. But so to quit, I have this, semicolon prompt, I'll go like Q. Okay, so I've introduced this general idea of processing several files that are similar or identical, almost identical, and do the same thing, for example, removing the 4th line for every sequence in every file. So we're already like entering into the more programming part of the lesson. So first I'll introduce the wildcard. I had looked that up in Italian, il metacarattere asterisco. So this is not, oh yeah, of course. This is not going to be a lesson on regular expressions, but you know, you will kind of get a feel for them because we will see many ways to specify things that are regular expressions. But let's like learn by practice. So excuse me, I have to like stay in the right place. So under data, as I announced, I have more than one FASTQ file. So let's list all the FASTQ files. Oh my God, there are many. This is not like very convenient. So, oh wait, no, I think I'm Q. No, I don't want to say less. I want to list. So ls. Okay, so what this asterisk character does is that it matches any character and any number of characters. So basically, everything that will live under this folder or subfolder, and that will end with .fastq, so the FASTQ file extension, will be returned by this command. But I can run other commands other than list. I can now I know how to count lines, for example. So I can go word count flag new lines. And you know, instead of returning the word count, the line count just for one file like we had earlier, it does it for every single file that corresponds to this pattern. So we talk about pattern matching in a regex being regular expression context. So this first file has 20,000 lines, and they seem to all have 20,000 lines. In this case, we can see it visually. And we also get a total here with this command. Yeah, and actually, since there are 320,000 lines and every file has 20,000 lines, if I divide in my head, it's not too difficult. I can see that I have 16 files, which is not necessarily obvious because they're not numbered like 1 through 16. So I know I have 16 files, but imagine, let's say I have 100, 200. I would not see this easily on my screen. I could not like ensure quickly that they all have 20,000 lines if I have more than one screen full. So one idea could be to save this output. So, you know, the output of this command, instead of having it just like out there in the terminal, I will redirect it. So redirection is done with this character here, with the greater than symbol, into a file. So I will call it file lengths. Can you still read? So here I don't have an output in the terminal anymore. It's been redirected into this file that we created for the occasion. So now we can check that this file exists over here. I'm just thinking that since we have this like long, cumbersome absolute path, maybe you would want to copy all these FASTQ files into your home, right? So let's do that. Normally we can do this with our knowledge of the basic functions. So for example, make a data directory, or you know, in my case I created a bash lesson directory, and in there I created a bash, a data folder. So I would encourage you, so from your home, make sure that you're in your home with print working directory. So let's go back up. Dot dot takes you to the cd dot dot takes you to the parent directory, so one level up in the tree. So if everyone is in their homes, please create, Of course, you can give it the name you like, but just so we all have a uniform experience. Create a bash lesson folder or directory, and then cd into it. Mine is already created, but if I had to create it, I would go like mkdir bash lesson. Then create a data subdirectory, and then cd into it. And so you will cp, so I let you, so this is not a real command, I'm writing it out as a comment. I'm using this hashtag symbol to tell bash that it shouldn't read evaluate print it, but it should ignore it. This is just for ourselves human. So you have the absolute path from like the earlier commands, and cp all these fastq files into the current directory represented by dot. And in here, as we just learned, since we want all the fastq files, sorry, I should remove it. Since you want all my fastq files, you're somewhere in your command, you would have this thing. You would have, this part, ***fastq. So let's make sure everyone has the fastq files in their homes. So we don't need to always give the absolute path to my files.
Where are these files?
Well, that's the absolute path that we've been using all the way since. So they are in here. So that's the absolute path.
So we substitute the brackets dot 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 with that.
Well, that's like an exercise I'm giving to you. So I'm asking you to copy my fastq files into your home.
Okay.
So yeah, in English it's CP, source destination. So the thing that you want to copy, and then where you want to copy it into. And then once you have them, you should be able to run this command and have the same output that I have here. Is it okay?
Yeah.
You have it? Is it all good? So file lengths we will create directly here. So file length that was like all the file. So let me clear this.
I was copying the
Uh,
because I didn't write. Okay.
So word count. I just want the lines. I don't really care about the words or the bytes. So now this should return something for you guys, right? And now we redirect it into a file here. So of course here I could also give an absolute path and go anywhere, but I'm gonna just stay in this data directory. So can you read properly here? Yeah. Okay, so now we are creating a new file. So we are creating this file not by doing touch or vim or nano like we saw earlier. we are creating a file by redirecting some output into a file, which is going to be created on the fly. File lengths. So now we have this new file lengths, and we can display its content. So we see that it lists all the files and adds a line for the total. And one way to retrieve the number of files would be to count the line of this file itself, since there's one line per file, and subtract 1, right? Because so you have 16 plus 1 for the total. And again, this is most valuable if you have a really large number of files. So maybe not 16, but 600 or 6,000, or I don't know. Oh yeah, note that, so now we'll introduce a very important notion, which is the notion of piping. You notice that we have done two operations, one after the other. So first we counted the lines of all the FASTQ files, and then we counted the lines of this resulting file. Instead of creating this intermediary file, if you like, we could directly use this output. So let me run the initial command again. So let me count the lines for all the FASTQ files. And now instead of redirecting it directly into, instead of redirecting the output of this command directly into a file, or leaving it out there in the terminal, I'm going to take this input and take this output and use it as the input for the next command using this pipe symbol, piping. So here, as I saw, I'm interested in counting the lines of this output. Right? So this command is producing an output. In this case, the output is, this list of files prefixed, if we like, with the number of their lines. And we want to take this output and make it the input of a new command. So it's building a pipeline. It's called piping. And so, as we know, it's returning 16, which is the number of files, one line per file, plus the extra line for the total. And this output itself, we could redirect into a file this time. So this would be, let's say, the final result of our processing, even if we're doing really simple things for now. So number files plus 1, let's say, plus 1. All right. So we've written our first pipeline here with like a piping operation and a redirection here. And if I display this final result, I'll see 17. Yeah, maybe something. So this logic of piping, of course, is extremely flexible, extremely powerful, extremely useful. So remember when we were talking about getting the second line of a file. Can you write a quick pipeline yourself to get, let's say, the second line, to display the second line of this file? Recall head and tail that we saw earlier. And head and tail take those flags where you can specify the exact number of lines that you want to display. So I'll write the instructions here. Please print. So print not like on paper, right? Print, it means like at the terminal in our REPL context. Please print the second line of file. I'm going to look at your answers. Remember head and tail. So you could get the first line, right?
Yeah, exactly.
Start with this one and build upon it.
Ah, okay.
So
We can pass
exactly. We want to pipe. That's the purpose of the. Any idea? No, quindi voglio solo la seconda linea, non le prime due, solo la seconda.
Sì, da soltanto
Ah,
un secondo.
Ah sì, scusami,
Sì,
non ho
sì, ho
ah sì,
sbagliato
sì,
io
ok,
prima.
ok, no, benissimo, sì. Ok. So I think a number of you had the intuition of like, getting the first two lines of this file. But since out of these first two lines I only want to keep the second one, then the idea will be to pipe this output. So this output here, I will output to tail to get only the last one. So the first of this line starting from the bottom. And I can do this not just for one file, but let's say for all my FastQ files. Since I know this very useful wildcard, the asterisk wildcard. Ah no, ma scusa, certo. Okay, so here I would get all the all the first two second lines for all the FastQ files. But then if I pipe it to tail, then I will just get this one last line. So we will get to for loops in just 1 second to be able to actually get the second lines of all FastQ files. I guess you've already heard of for loops more generally in programming. Before we do for loops, I just wanted to showcase, so I'll go back to my local terminal. So here I'm not connected to the cluster, right? I'm here at home, in the home of my personal laptop. Who am I? So for example, this, I just want to show it because it's cool, even though it's not the only way to transfer data files, don't get me wrong, but like it maybe it shows you a use of the piping concept that's pretty nice. So if I SSH into the cluster where I'm at over here, hpc2.unitn.it. I saw that I could run a command from over there between quotes. So I could, let's say, here, so yes, I am in this data subfolder. I could compress this data subfolder, which contains all my FastQ files, so all my data sets, and send it over the network, and then decompress it over here. So in real life, there are other programs, rsync, very nice utilities that let you do these kinds of things. But anyway, that's one example. So tar, maybe you've seen this program to create archives, to create tarballs, ZCF. And then, so this will create an archive, so it will compress your, wait, I need to specify which file I want to compress. So let's say, bash lesson/data. So this will create a .tar.gz. Yes.
So all you have to install something upon SSH or SSH knows tar by default, has
No, okay, no, it's not that SSH knows tar. It's like so I think that tar is available pretty much everywhere on Unix systems. I may be wrong, but yeah. But like, so you have some of these utilities. That's also why I was kind of promoting Vim, in the sense that if you connect to any computing facility, you will find Vim will be available. So you don't need to ask a sysadmin to install you this thing. So yeah, exactly. I mean, that's actually a very good question, because I said there are alternatives. So like, if you really needed to transfer big data files from one place to another, there are many, many ways to do it. But since tar is a very old program and it's very standard, there are large chances that it will be available, whereas you know, maybe rsync is not precisely. I don't know. Yeah, it is available, but yeah, okay. So I will pipe so in this case, the output is this compressed archive, and it will become my input for decompressing over here locally on my laptop. ZXF. So I'm asked for my password as expected, and maybe that will take a little bit of time because it needs to create the archive over there. And then, oh, and let's see what happened. Now, do I have, oh, okay, yeah, so if I just do ls, it's not so clear, so I will introduce my favorite flags, even if the specifics will be detailed maybe tomorrow. So personally, in my real life, I never run just ls. I always run ls with these flags, lrth, where, so L stands for long, so it will display files in a long format with a bunch of details, so not just the folder or the file, but when it was last modified, who owns it, and these permissions. So again, we'll talk about permissions tomorrow, not today, because we can't do everything. Then the H stands for human readable. So instead of having the size of files and folders in bytes, it converts it like it will be, you know, kilobytes, megabytes, etc. And RT stands for reverse time. So it will sort and order my files and folders according to the latest changes done to them. So if I only use time, I would get the most recent, the most recent modified file or folder on top. Personally, I prefer having the latest at the bottom. That's why I use R for reverse. Also because when you have more than a screen full of content, you know, this will fill up your screen, and you know, I'm usually most interested in the latest change. So anyway, it's like now 10:07, and at 10:05, so 2 minutes ago, during that time I've been explaining you things, we just decompressed this like bash lesson data thing, and here I have all my data sets like I have over there. So that see.
Just to clarify, because
Yes.
it wasn't clear to me.
Tell me.
So what you did, you were on your local machine.
Yes.
So you kind of connected to the cluster.
Yes.
Then you applied the command.
Yes.
With
Exactly.
and then the output of this command that would have been an archive
Yes.
file.
Yeah.
It's like you downloaded it on your computer and untagged it.
Exactly.
So you had the uncompressed file.
Yeah. Yeah, absolutely. Yeah, perfect. Yeah, and in a way, so I admit that it's a bit complicated, but that's precisely to kind of illustrate the power of SSH and piping. So, and again, in maybe with your actual facilities, and maybe you have storage spaces, I don't know, at the university, which encourage you to transfer files in other ways, you know, that's perfectly valid. But that just kind of sums up many notions that we have seen today. Okay. But it's not like you have to memorize this by heart or anything, of course, right? Okay. All right. So now we will introduce. So I will go back to the cluster. Yes, here I am. Okay. Now that I've introduced the L flag, even if it shows a bunch of cryptic things, again, I promised you that tomorrow we'll go a little more into details. But I can use it from now on because it's not coming from nowhere. So for loops, so yeah, you've probably heard of it. For loops are relevant when you want to apply the same thing over and over again to several elements. So in our case, we're talking about all these FASTQ files. And as I showed, like I was being too naive and too quick, if I only use the wildcard, so let's say I want to apply one command to all the FASTQ files. No, that was, we wanted to retrieve the second line. So we started by retrieving the first two lines. Okay, that works. We do get the first two lines. So it's more than a screen full because we have 16 files. So yeah, it starts over here. Okay, yeah, so for this first file, the one that we've been using most so far, all the way to the 16th file here, we're getting those first two lines. Okay, I'll write the command again. Head, flag N, star FASTQ. So that's great, and I didn't need to learn about or know about for loops. But when I was like, okay, but I don't want to just get the first two lines, I want to get the second line only, and then this piping, well, didn't work because, well, it's just being logical. It has a given output, it ends this way, and it's going to retrieve this last line. That's what tail does, and that's what it should do. That's what it's expected to do. So I need something else in my toolbox to be able to get the second line for each and every FASTQ files. So we'll use for loops, and in for loops we need typically variables because, so for example, if I go, yeah, let's introduce variables in Bash first. So usually, very often they're written in uppercase, but they don't have to be. So if I give them a value, then the way to access them will be with a $sign. So I will also introduce the echo command. So as echo says itself, it echoes back what you just gave it. So for example, if I say echo hello, the terminal prints back hello. So if I want to display var, I'll have to go like $var. But var, could also be hello. So go like echo var. I could specify. I think that doesn't make any difference. Quotes or single quotes. Now, if var was like, let's say, ls. You see that echo is very important because if I just run var, like the variable var, since it has ls as a value, Bash will actually execute ls because it understands it as a command here. Let's say when let's say var1 equals 1. If I go like, yeah, that doesn't do anything. Yeah, so let's introduce for loops and just type a loop. So I will loop over at least 2 files then. So for srr 307023 _1.fastq. And I think there's one with the same name but with a 2. So sequentially. I'm writing a list of files, 30, 70, 23, 2 dot fastq. And then when I type enter, so that's where I needed my variable. So I have a list of file that I will do things with, and I want a variable that will take each file name one after the other. So I introduce file in. I'm calling this dummy variable file. And now when I type enter, I don't get my regular prompt with the $sign back. I get another prompt which is expecting for more input on my part, because when bash reads 4, it knows that it's expecting a set of instructions. And to start with the instructions, you go like do. And so for now, we're just going to echo back those the values that the variable takes. Echo file, just so we know what we're doing. And when I'm done with instructions, I type done. So this works, and that's the syntax. So the file variable loops over this list. First it takes the value _1, then _2, and it echoes that. Now notice that if I type arrow up, bash displays my for loop. Basically those line breaks that I did, an alternative way to write it over one line is to use those semicolons. But okay, let's not be lazy. Now I will just loop over all the files that are fastq files. So we've seen how to do this. So now this list, maybe I don't know in advance how long it is. I don't know all the elements. I just know that I want to do something with all my fastq files. Do. So for now, I'll just, I'm not doing data processing. I'm just like returning the file names. Okay, these are like the 16 files that I expect. So now I know that when I am inside the loop, in this place, I know that I have a hold of one file at a time. So first iteration of the loop file is really just this srr _1.fastq files. So if I want to do this processing that we just did, head n minus n2, tail minus n1 to get only the second line, I'll be able to do it on just this one. And then on the second iteration, when file takes this value, I'll be able to do this command only on the second file. So in spirit, that's what I need, to achieve the virtual problem issue that I submitted to you when I introduced bash and its power and its use. So in this case, the program will be fastq. Vi lascio fare. Say, let's just make sure that you can do it. So print the second line of all fastq files. Yeah, so I tend to type, that's like I think my convention, but I type either fastq or fastq files when I talk about the format. Se avete domande più particolari ne possiamo parlare durante la pausa caffè. Tutto bene? Mhm. Sì, sì, sembra... Si può sbagliare comunque.
Ok, sbagliamo. Dani, quindi per te.
Sì. Mm.
Grazie. Non lo so.
Allora, head e echo sono due comandi. E invece un comando si aspetta l'argomento su cui applicare il comando. Ma c'è qualcosa, solo che...
Sì, ora ci prendiamo.
Ottimo. Okay, so some people have something already, and then I'll invite you to try and... So the output is not being captured or saved anywhere, right? It goes into the terminal. So what if you wanted to save that output in a file? Let's see. Yes, but yeah, you will be missing something. So I think that I'm like leading you to failure. So I think lots of people had the intuition of starting this way. I would do to start taking actions on file. I think it never hurts to print the looping variable so that we know where we're at. That I think that never hurts. But there is this pipeline that we did earlier that we wanted to reuse, right? So we went like head, first two lines. Head of what? Right? This variable that I access with the $sign. And then out of these first two lines, I want to get only the last one, so with tail. Okay, so let's start this way. So done. Okay. Now, so let's type it again, and it gets in your fingers, and it's the best way to learn. So do echo file head minus n2 tail minus n1. Oh, okay. I wanted to redirect this output into a file. Oh, maybe I can do it here. Maybe it's not too late. So second lines.txt done. I'm not sure what I've done. It shouldn't take that long. Yeah, okay. Okay, so I'll just rewrite it properly. Oh yeah, right. Okay, so sorry, that syntactically that means something like so I couldn't just
So when do you write head and to...
yeah.
Don't we need to put it what? Head of what? Like, does it understand what...
Oh yeah, no, indeed. Thank you. Yeah. So head of file. Right. You know, even if it knows that we are in the for loop, we are at file, this given file, we need to know if we're doing something with that file or not. And here, yeah, so I want my, since we've learned the redirection with this operator, my my normal leaning is to go like, okay, you know, let's save this into second lines.txt and be done with it. Except that if I print out second lines, I only get the very last, the last of these second lines, because every time in the loop, this file got overwritten. So the nice thing is that in Bash you have something other that's very complementary to this use, and it's like the double, I don't know if I can call it double redirection or append. So I will copy paste this. Normally I should type it all, I feel lazy. And if instead of redirection you use this like redirection with append, then it will not overwrite the file, it will append a line at the end, and done. And now when I display the content of second lines, it seems okay.
17.
Exactly. So but if I check the length of second lines, oops, yeah, I get 17 lines, not 16, even though I have 16 files. But that's because when I run that program, so we're already programming, now I can say it with no shame. Well, that second lines.txt file existed, contained one line, so the other 16 lines were appended next. So as you can see, exactly this line is exactly this line, this sequence, and the other 16 lines were there. So of course I could, I could kind of go manually and like edit out the first line, or I could go like, okay, yeah, my processing is to go like tail. I'll just get the last 16 lines, and I can redirect this into the final file that I want. I can always work my way around. But let's say if you're writing a program in general, maybe what you would want to do in this case is first remove this second lines.txt file, and then run your for loop that I will access like this with arrow up. And in this case, when I count the lines of second file, I have 16 lines. Okay, I think, are we approaching the coffee break? I think we may have just like 3-4 minutes left. So I will just use these. Yeah, do you have a question?
Yes, sorry. So when we do the pipeline, like then we put the file pipe tail. There we don't need to specify the file because it's obvious for piping.
Yeah, so that has nothing to do with the looping. It has only to do with the piping indeed. Yeah, so it's like here you get an output. So you're running a command, so you're getting an output. Mm-hmm. And when you write pipe, what pipe means is that use this output as the input of the command following.
Okay, so is it not necessary or better not to put like...
No, it's not that it's not necessary. It's like if you were writing something else, it would mean something else. So it's like when you write pipe and a command, there is an input, and the input is the output from the previous command.
Okay, so if I wrote by mistake,
yeah, let's
tail and one.
Yeah, we can try it.
That would be a mistake.
Yeah, so here I have a command, so with an output, and then what this thing means is I'm piping this output into something else, and if, so basically I think you're suggesting that, instead of doing this, you're saying let's write another file, right? So let's write the same thing.
So if you write the same one, maybe it's like okay, but too much.
So you have an error, right?
First cube.
Oh, excuse me. So, oh wait. So now I have to see what is the. So let's say what. So what is the output of this?
Like when we put the star, so it combines the input, that is the output.
Ah, yes, yeah.
That file.
Okay, yeah.
So it creates like just one big
Yes,
input.
exactly.
That is a combination of the first one and the second one. out just the last one.
Yeah, so it becomes a list. Yeah, so basically it's like, so here you have this command, tail minus n1. So like basically give me the last line. So it will not give you the last line of this, it will give you the last line of output of this plus that.
Okay.
So it's this idea that the output of the first command will always be the input of the second command.
Okay,
Yeah, thanks Alberto. Yeah, so maybe to wrap up the first half of this lesson, I'll just say a word about the standard streams. So standard input, standard output, and standard error. So, you know, I kept saying, you know, the output is in the terminal. We're not capturing the output. We're not saving the output. So just like, so by convention, yeah, the output of a command is the standard output. So like the way to say, when I go like, you know, I'm redirecting this into a file, I'm redirecting standard output into a file. Standard input is basically what you pass to the command. So when I go like -l s fast q, this is my standard input. But I could also maybe like right here, like actually I never do this, but okay, I wanted to mimic the fact of like typing out a file in the command line, but like basically what's coming here is standard input. And a standard error is like when you run, for example, a command that doesn't exist, so like car instead of cat. Or if you run it on maybe on a directory, rather than a file. And an interesting thing to know is that, so if I remember well, the codes in the shell for standard input output error are 0, 1, and 2. So if you want to capture the errors of your program, you go like to redirect, let's say errors.txt. So see here, this error doesn't get displayed at me, but it gets like sent into the errors file. And I think this can be very precious. So when you do your scientific computing jobs, you know, there will be times when there's an error for whatever reasons. Maybe, you know, it's trying to read a file that doesn't exist yet. Maybe it's trying to write into a folder that doesn't exist yet, or that's full, etc. So like you will have errors. And so at the end of your commands, it might be useful to use this, like, you know, redirect errors, so that later on when you discover that, you know, your computations were not carried out, etc., at least you can read the errors. I mean, of course, there are other ways to debug. You can look at the error logs in other places in the system, but anyway, that's always good to be aware of. Okay, I think that's pretty much what I wanted to tell you before 10:30, and I'll see you again in 15, 20 minutes.
Thanks, Maria. Ricordate il foglio delle firme,
Io alle 11:30 devo scappare perché devo portare mia figlia che deve fare un intervento on Decnite, quindi
quindi a un certo
quello
punto...
dopo io a un certo punto scapperò a me.
No, no, niente offesa, va bene, ok. Ah,
Dai, ottimo, così mentre faccio sta cosa mi metto lo streaming, vedo anche come
ah, ok,
funziona.
quindi... Bene.
Beh, diciamo che seguo in remoto. Va bene, dai, buon proseguimento.
Grazie, grazie. Ok, mi sento... Sì, dobbiamo controllare per lo streaming che tutto funziona. Ok, quindi ricominciamo. Allora, ci siamo lasciati con questo discorso di errori, messaggi di errore salvaguardati da qualche parte, così almeno si può capire cosa è successo quando il run, il job non è andato a buon fine. Quindi parlando di tracciamento di... sorry. So talking about tracking and keeping track of things, we probably want to keep this little program that we just wrote somewhere. You know, it's only in the terminal right now, this for loop, and when we close this window, when we log out of the cluster, it's gone. So we want to keep it and we'll save it in a file. And we'll save it in a file with the file extension .bash so that we can execute it, run it with bash later on. So I will kind of force Vim onto you. But I mean, if you really want to, you can use another editor, of course. So I'll call it demo.sh. So this file extension is meaningful. Oh, sorry, I had one already, so demo.sh. If I remember correctly, we said that first we wanted to remove. What was the name of this? Second lines, right? Okay, so that's the name of the file. We want to make sure that, so insert I, and then I can type things. So first I'll remove second underscore lines.txt, because when I count, when I write the second lines, you know, I'm using this double redirect which append lines. So we want to start with like no second lines saved, written out whatsoever. Now I write my for loop so that we get to memorize the syntax a little bit. In this for loop, we're looping over all the FASTQ files. Oops. Okay, I don't know. 1, 2, 3, 4. I'm indenting. You can indent with 2 or 4. I mean, in my real life, I don't write many bash scripts, I have to say. In my real life, I would probably write this in Python, but it's interesting and important to learn the concepts underlying what we're doing. So we said head, so first 2 lines. I'm piping this output into tail and 1, and I'm redirecting this into the file second lines.txt. And I think that was it, right?
No, there is an in
Oh, sorry. For, wait, do. Grazie, non si vede bene. Ok. Grazie. Okay, so I have written my first program in Bash. I'm happy. So it's saved somewhere. And now I can run it with the command bash demo.sh. And I can check that it did something by running my favorite version of ls with the LRTH flag. Yeah, it's 11:05, and at 11:05 we just wrote second lines.txt. Okay.
Did everyone successfully save the beam?
What was the command?
Okay, after
So I'll display.
no, just to how to save in
Save
Vim.
the beam.
Ah, yes, sorry. I always underestimate the difficulty of Vim. So when you're done here, you want to exit the insert mode. So you press escape.
Okay.
And then now that you're not in insert mode anymore, but you're in command mode, you go colon, like this, WQ. Okay, and let's keep this demo.sh file for later, for this afternoon when we study version control. So now let's see how we can look for and hence find files based on specific criteria, and then we'll see how to find things inside text files. As the name suggests, it's called find. So find will let me find files, or actually not just files. So let's look for things in the current directory. So dot is the current directory. And I can specify things about the file names. So for example, like we've been doing, things that end with .fastq. And I could be more specific. I could say that they should have type file. Or I should just list all the things that, okay, no criterion on the name, but type D for directory. Okay, so there's actually no directory within data aside from itself. I don't know if maybe you've heard of symbolic links, symlinks. So they would be specified like this. Okay, I don't have any here. And if you don't know what it is, don't worry about it. But if you had to look for symlinks in a specific place, here it's the current directory, but maybe we would be looking elsewhere, yeah, oh, it's also useful to know that there's this option. So mtime will tell you, will return the things in the current directory. So current directory because I specified this, but it could be another place, that were edited within the last day. I think. Let me look for. So when you don't know how to use a command, you can display the man pages for it. So you go like man and the command man find. And here, so I want to see how I can use mtime. And I type next. So yeah, to find mtime, I went like /mtime. And that's something from Vim. So again, that's why I told you, if you know Vim a little bit, it helps you on the Unix system in general, not only for text editing. So /mtime gives me the instances of mtime in the manual for find. The next instance I get by typing n. Okay, files data was last modified, yeah, so 24 hours, 1 day ago, since, And I think there's also by minutes. Wait, so if I go like m min so I don't know what it means. What it? Wait. Okay. So here, let me find a directory. Yeah, so there's the current directory and there's data. Find. Okay, so in theory this is very useful, but as you can see I'm not used to using it. So I don't know, Alberto, are you familiar with this thing? Okay, whatever. Like when I practiced it, I mean, it's like the criteria is supposed to be, so like, find is very useful because you can specify, what the name looks like, what the type is, and like this would be about like when was it modified within the last 30 minutes, or was it modified?
Yes.
Yeah. So I would.
You created something in this span of time.
Oh yeah, right, because we had the coffee break, but still, it should be within the last 45 minutes, I would expect.
Can you do a less one side?
Right. Yeah, see, so I would expect this to come up, That's weird. Okay, let's leave it aside but so in spirit, and again, like maybe in practice you will have other utilities, but there's this idea that you can find files based on specific criteria. And now we'll see grep, which stands for Global Regular Expression Print, and that lets us find things within files. So for example, remember I think there was this length word in the FASTQ file. See, so it's returning all the lines that contain length, and plus it's highlighting length in red here. This is a very long output, so maybe that's typically something I would like to pipe into less, right? So I can just like scroll down bit by bit. But I don't get syntax highlighting in less. Well, syntax, or I don't get like the highlight of this regular expression. So here,
I think it may be a problem of rounding. If you put 0 instead of 1,
yeah.
you get the list.
Thank you. So let me try. Oh yeah. Okay. Beyond. Okay. Oh right. Okay. Sorry. So I enter. Non è entro 30 minuti, ma oltre. Ok. Quindi m time.
Put 0 in the book.
Okay. Right. Grazie. And that would also, let's say.
For the m-min
Yeah.
it wants the exact.
Okay. Okay. Thank you.
66 minutes.
Yeah. Like, did I edit something 66 minutes ago?
Yes.
Okay. Okay, so maybe. Yeah, not within. Okay, thank you. That's why. Okay. So, yeah, so that returns the files modified within the last 24 hours. And as you can see, it doesn't include the FASTQ files, because the FASTQ files I had copied in there a few days ago already to prepare for this lesson. So, okay. So see, when you don't know what's going on, always go back to reading the docs, reading the manual, as they say. All right, so find is for finding files or folders, and grep is for finding specific text within files. So I mentioned the term regular expression before. So it means that we can do pattern matching. So it's like more general and more open than just a specific word. For example, so wildcard was an example of it. So for example, instead of grepping for, so searching for length, I could be like, actually, I'm searching for whatever word that starts with L, then there's something, and then it ends with NGTH. And it would return the same thing, because in this case, I mean, LENGTH corresponds to, L, anything, any number of characters. So for example, okay, let's, just to highlight the difference, let's copy this file into a modified version. And let's open this modified version. And let's edit it out. So in Vim, we go I to access the insert mode. And here, instead of length, I'm going to write length. And here, length. And here, see? Okay. And so notice I didn't do it on the original file, right? I copied the file. So it's just to play around with it. So now if I grab for this pattern, this regular expression, as it's called, on mod, and I go less, where is less? So as you can see, it is returning not just length, but all these guys. Wait, let's see if I can get the, yeah, oh no, I know, let's pipe it into head. Oh no, but it's, okay. I wanted to get this like red highlighting, but whatever. So these first 3 lines contain something that matches length. So that's the wildcard that we've seen before. If you were to use a dot notation here, it would actually match anything but a single character. So it's like it would be anything, but just one, not any number like the star. And if I run this, you see that this one doesn't get picked because it doesn't match. It matches this pattern, but not that one. Okay. Whereas, so if I wanted to match that pattern, that I could go like 1, 2, okay, and I would get it. Yeah, and now, so to go beyond these like text data manipulation, it's also interesting to introduce SED. SED stands for Stream Editor. It's also one of those very old commands. And again, even if you don't use exactly SED at the command line like this, you will see that many, many tools are based out of SED, grep, and awk that we will see in a second. So let's say if I wanted to replace, let's say, all the E's in length by A's to write length, I could use this utility. So SED here, between quotes, you will pass the expression. So you will substitute length by, let's say, length. And here I'm specifying G to mean globals, like everywhere in the file. Well, which file? Let's keep using this file, 32, no, 23. And so if I just run this, well, it will do it, but then, you know, that's like kind of the issue I have with long files, like, so I could pipe it into S. So see, it has substituted length with length. And if that was interesting at all, I think in this case it's not very interesting, but let's imagine I have an error that has propagated everywhere. You know, that's one way to fix it. I will redirect this into, so how can I call it this? Length version. .fastq. So there's many things you can do with sed. So you can, as you see, and again, the logic is one of regular expressions. So even if here I passed a specific word, you know, if I replaced this E with a star, then it means that not only length would be replaced by length, but maybe length or length, or you know, any other pattern matching L something and GTH. So now let's learn how to remove every other line in a file. Actually, you could do it with sed. I don't. In real life, I would probably look it up online, but that's a good pretext to introduce awk, which you will hear about again, or again, even if you don't use it directly for your computing culture, it's like necessary to have heard of it. In this case, unlike stream editor or global regular expression print, this doesn't mean something in English. I think it's like the initials of the three creators, the three guys at IBM or Bell or something like that created it in the 60s or something. I double check on Wikipedia. So here the instruction that we want to pass to a file to remove, you know, not this line but that line, not this line but that line, and all along the file is written this way: F and R in capitals, modulo 2. And yeah, let's apply this to this length file that, okay, let's keep this series file here. So again, okay, I'll just type it into head so things remain visible on my screen. Oh, so see here we have removed the raw sequence and the quality score. So for every sequence, we've only kept the first line, which is its ID and descriptor, and then the third line, which is redundant and just with a different initial symbol. If we wanted to remove every other, no, so how would you call this? One line out of three. So all the third lines and on and on and on, you would go like this. So actually, let me pipe it into less. So I see that, yeah, you know, this like redundant line with the plus, and that kind of copied the first line. It's not there anymore. We just have this like ID, raw sequence, quality score, ID. Oh no, but then that's maybe. Oh yeah, well, it's not a multiple, so anyway, so let's be careful. Let's test what we're doing. Yeah,
Okay.
because
This way it looks like magic. How AWT works. So what does the command?
yeah, well, the thing is, it does many things. Okay, I think the most famous thing it is known for is accessing contents of lines in a text file as variables. So, for example, in a text file that contains this line, since we have two white spaces here, one white space here, and a second white space here. So that would be, even if they're not words in English, let's say there are 3 words. So awk will let you, will identify this with the first variable, so that will access like this. This will be the second variable, sorry, not this, up to the next white space, will be accessible this way, and this one will be accessible that way. So I think that's like the most famous, yeah, let's run it, see. So awk, the syntax is a bit cumbersome. So you go like print this third variable, close, and let's go one of my FASTA files. And let's pipe it into head so we don't overflow our screen. So as you can see, so it has kept only those third variables because, well, in the other lines, so remember how these files look. Since the other lines only contain one word because there's no white space, basically the third variables that are available are only for those lines where I have length.
So by default, it has a loop over all the lines.
Yes, exactly. Yeah.
And I can specify an action on the line via the
Yeah.
curly parentheses.
Yeah. Or see here, there's no curly parentheses. So okay, to be honest, I'm not like an expert in awk at all. So I think it's like very interesting to know like by culture that it's a very basic tool that has existed for a long time, and that many modern tools are built upon this, or SED, or grep, or all of them. So again, in my real life, personally, I would end up doing these things in a Python program, for example. And also, but sometimes for very quick lookups, or even let's say, for example, I'm home, and I'll just do this fast, SSH thing, and maybe control that let's say I know what kind of files I'm printing. I know that the third column should always be whatever 0 or 1. So from home, I'll do like SSH, awk print. This thing which still is simple and control something, and I won't need to launch Python. It's great, as you can see, it's very powerful. But I personally don't know all. I mean, again, I could go like man awk and study all the manual of how to do things, and I definitely don't know it by heart. Yeah, or look it up online because other people will probably have written it. Yeah.
Can introduce
Yes.
1 minute awk, the syntax, to shed some light on that syntax.
Yeah. So like, for example.
So
Yeah, maybe that's not very helpful to
I-
see. Yeah, go ahead. Yeah,
I can flash my
yeah. The general syntax of the command.
Yes,
Yeah,
yes.
yeah.
So is there a choke?
Ah.
No.
Oh yeah.
So usually when you program, you find very often yourself in this situation. If condition, then take an action, perform something, okay? And awk performs this on each line of a file, or multiple files, okay? The syntax of awk is this. Condition,
Yeah, magic.
and between curly braces,
Yeah, but I don't even know.
My
I will tell them. Yeah.
okay? Awk, can you read from there? The default value of a condition for awk is true. Okay? So if you don't put this condition, it assumes that this action should be performed on each line. Okay? The default action is print the whole line. So if you don't put the curly braces, it will print the whole line for which this condition is true. Okay? So let me say this is true, default value, and default action is print $0. Okay. $0 is the whole line.
Yeah.
$1,
yeah.
as you said, is the first field. Okay. Questions on this? Okay. In awk, each line is called record. Okay. So NR is one of many built-in variables of awk. It's number of records, which is the line number. The first line is number record 1, second line number record 2, so on and so forth. Okay? Questions on this? Just one question for you. A5. What do you think this command will do? oak. Number of records equal to 2. Input 5. What do you think this guy will do?
Consider the second line of
Mhm.
Perfect.
Yeah.
So this condition is true only on the second line. Okay. Remember that oak processes one line at a time. And then perform the default action. That is print $0. Okay. So this is another way to print the second line of a file. Okay.
So you don't need to pipe in this case.
Yes.
Okay.
If you put two files, like file 1 and file 2, .txt, what happens? It will print just the second line of this one, because we have one big input, as before, and it print just one line. Oak is super smart print. There is another built-in variable, that is one that Marianne uses, that is file number of record. So it is a number of record relative to each file. This will print the second line of this file and the second line of this one
Without needing a loop.
without needing a loop. The guys who developed oak decided that as long as I process the files, I populate this variable. Okay. Questions on this? Now let's go back to the first magic.
High up, yeah.
Up there.
Yeah.
Now there is this one. You know this operator, what it does? It's modulus, right? So this performs a mathematical operation that returns the remainder of the integer division of number of records and 3. Okay? So for example, 1 modulus 3 gives me 1. Okay? So on and so forth, just the multiples of 3 give me 0. Okay? Remember that the syntax of O is condition. Okay? That is a boolean, true or false. Now, how usually numbers are translated into booleans? Here, you have to ask yourself one question. Are there any errors? If yes, I would like to know which type of error. And errors can be infinite, if you will. Okay. But there is just one number that tells me if no errors happen. Okay? And it is 0. So this is translating to true, and it is translating to false. The other way around. Yes, the other way around.
One or anything else, basically.
Yes. The other way around. I'm sorry. Okay.
So this will be only satisfied for line numbers that are multiples of 3. So we'll return the lines that have a record number multiple of 3. Yeah, I just wanted to add also general context for your data-driven mind, that all this assumes a structure of tabular data. When we are talking about records, lines and fields, that in your head you can think of a spreadsheet, right? You can think of a table. It's we have all these records that we will iterate upon using awk, and the fields are, you can think of columns or variables depending on the specific language that you're using, but the concept is one of tabular data.
Sorry to interrupt.
No, thank you so much.
No problem.
I think that was helpful because, of course, it's fine. Don't worry. So right, yeah, it shouldn't look like total magic. Also, if it looks like magic at first and impressive and powerful, why not? And we get to dig deeper and clarify. I actually wanted to. So here I retrieved this third field or variable in my FASTQ file. I wanted to pipe it further, so let me get this. Let's say I'm only interested in the actual length, so the number. So the equal sign is not the default separator, because as we have seen, the default separator is the white space, but awk is so flexible and convenient that I can actually specify, for this one, please use the equal sign as the separator. So here we'll go print, like we just did. And this command, this instruction bears on a given FASTQ file. So I saw that the output of this command is this. And here I can go like pipe, awk again. And I said I wanted the second variable, so that's going to be, oops. Print $2. And specifying that, maybe I'll put it on front because it's a flag, that the separator should be the equals sign. And then I'll pipe this into head, just so. So here I have achieved this like text separation of length equals 101 to retrieve only 101. So again, you kind of you sense the power of such commands to be able to filter, change, modify, replace, change the order of whatever tabular data you might be manipulating when it's saved in a text file, text format style. So I only displayed the beginning, but basically there's like 101 all the way long, all the way to the end of the file. What if I wanted to ensure that 101 is really the unique value, like the only length, like all my sequences in this file are of length 101? How could I ensure this? There's a Unix function, Unix command called unique, the short way without UE at the end. So because as we've seen, commands usually kind of do what they mean, like find, finds, ls, lists, cd, changes directory. You might be like, oh, sure, I'll use unique to be like, let's make sure that I only have 101 as a value. But when I run this, that I just get like the same thing. It doesn't look really great. So I'll just pipe into less so we can scroll. Okay, so unique is not really doing maybe what I'm expecting intuitively. And the reason is that unique functions in a certain way, so it will filter out duplicates. So in Spirit, if you're filtering out duplicates, you're like, okay, like this, I will be left with only the unique values, the distinct unique values. But it's doing it side by side. It's doing it adjacently. So here actually you have 101 followed by an empty line, 101 followed by an empty line. So when unique is going through all the lines, all the records of your file, it's actually not finding duplicates. So it's keeping everything. It's going to be like, oh, the next one is different, so I'm keeping it. The next one is different, so I'm keeping it. So to avoid this, you have to enrich your pipeline a little bit. So arrow up to get my latest command. And before I use the unique command, I have to sort all those records. So I'll go like, so actually let's be gradual. So I'll pipe the so the output of this, as we've seen, is this series of 101 empty line, 101 empty line. If I pipe this into sort, and I pipe that into less. I go like, okay, so I have a bunch of empty lines. I think that's what's happening. Oh, this might take a long time. So let's get the tail of it. And all the one-on-ones are afterwards, because the sorting has like put all the empty lines first and then all the one-on-ones afterwards. So in that case, if I apply unique, that will return the, so actually there are two unique values, empty line and one-on-one. And that's more like what I expect, but as you can see, it takes some sorting first. So I think that Raffaello had something else in mind, like to compare this with a use of awk.
Yes.
Do you know what he had in mind?
Yes.
Yeah. Yeah, can you
So the beauty of pipes is that, like real pipes filled with water, combine two programs. So suppose that the output produced by the first command is like water, a small stream that starts to flow, and enters this pipe. So as soon as some water is produced, this guy can work on it. So the beauty of pipes is that if you have many pipes, you can achieve untrivial parallelization, provided that you have enough cores, okay? For free, you have parallelization for free. Just put in some pipes. There is some commands that kills this parallelization. Sort is one of them, because you cannot sort something until you have read all the values.
Yeah.
But awk has a new awk. The awk is a command. It's a programming language. There are many implementations. The most famous new awk. That is the one that you can find, on Linux machines. Okay? Mac uses as by default a different awk. So GNU awk has a so-called multidimensional arrays. Okay, arrays that they are actually not arrays. Who of you are familiar with data structures? So, just for you, arrays in awk are hash tables. Okay, what are hash tables? They are arrays of arrays. Do you know what an array is? Is some of you that doesn't know what an array is? Okay, don't worry, there are no stupid questions, okay? If you don't know, say it, okay? It may be stupid not to ask. So an array is something that can be accessed through an index. Okay? Suppose that this is index 0, 1, 2, 100, whatever. Okay? In a hash table, at this index, you can access many more times. Okay? How can I get the index in a hash table? I need to apply an hash function to a axis. Okay? The output of this hash function is a integer value that gives me the index. Okay? So for example, I can apply as a key, I can use as a key $0 or $3 in this case. Okay? I use something as a key, so I feed my hash function. Awk has one built-in hash function, very performant. And I ask to my hash function, which is the index, which is a number. I tell you people 101, and it returns me back an index. Okay? Arrays in awk are by default initialized to 0. Okay? This is useful. Okay?
it will enable us to sort before we have collected everything?
No, the point is not, we don't need to sort, because sort is blocking.
Yeah.
I can exploit this feature to select unique values, because same values will give me same index. Okay? So I run it down, and then we comment.
Careful, because it's a French keyboard. But
Okay. So more challenging than what I expected. This one. Oh, careful.
Oh. Yes. You're doing good.
Which
23 underscore 2 and autocomplete.
Can you read? So this is kind of the shortest useful command program in Oak. Exclamation mark. Okay. X. X is a name for a built-in for an array in Oak. Okay. You can choose whatever name you want, Marianne or Alberto, Hippo, whatever. Between bracket is my key, okay, and then plus plus. What does it mean? Okay. Remember that I didn't put the curly braces. Okay. So the default action is print wall line for which this condition is true. Okay. Or if I want just to print the third field, okay.
L'hai trovato.
Print.
Dollar signs. Alt G. Yeah.
Oh.
Perfect.
Okay. Now let's decrypt the condition. All the values are initialized by 0 by default. Okay. You know. So I say call your hash function and return me the index of $3. Okay. I lost it from scratch. So Oak starts reading the file that I give as input line by line. Okay. For each line, he knows that the third field can be accessed through $3. Okay. Questions so far? Now I want to use some more advanced, is a data structure that it provides. Okay. So imagine an array at this index, where this index is actually a key. It doesn't need to be an integer. It is a string. Okay. To this string, Oak applies a hash function that returns me an integer, okay, such that I can access an element of an array. Okay. These elements of the array are initialized by default to 0. Okay? I stop here because in this condition it's the other way around of what I wrote there. Where 0 means false and
Yeah, anything non-zero should be true.
yes.
Non-zero,
I
different.
don't-
Well, exclamation mark. Introduce it, no, this way.
Yes,
think
and
so.
I don't know, other different from 0
Else, yeah.
means true. Okay, it's the other way around here. here, and that's why I came here and was thinking, because
True.
Uh,
Yeah.
I don't know why it works in this way, so please
Yeah.
forget for this for a little while.
We'll look into it in details. Yeah. Like that.
But in this situation, are there any errors? No means false. There is just one number that answers to this question, that is 0. Are there any errors? Yes. If yes, which one? A lot of type of errors that we can do. Okay. So by default, if I just say x of dollar $3, the value is interpreted as false. Okay? Because by default, all these values are 0. Okay? 0 means false. Okay? No errors. No, false. Are you following?
Sorry,
Yes.
I don't understand. If with x $3,
Yes.
we are accessing the index of $3
No,
or
we-
the vice versa?
No.
We are accessing the value,
Yeah.
This has index $3.
Yes.
yes,
Yeah.
associated with the key
Yeah.
$3.
Yeah. It's like, yeah, you can think of it as an index. It's just that it's not just an index. You can think of it as a label. You know, that's why Alberto keeps saying key, because you know, index is 0, 1, 2, 3, etc. Whereas, as you see here, it can be a word, a regex, a character.
Okay,
So
can
key.
be
Yeah.
also, I don't know,
Yeah.
time.
A coordinate. But yeah, I think
Yeah.
it's the coordinate. Yeah. Oh.
Then we do something. We add exclamation mark and plus plus. Who of you had already programmed in any language? All of you. Perfect. So if I have a variable suppose that a equal to 0. You know the difference between no. If I want to print in whatever language, okay, I expect to see 0, right? You know the difference between these two syntax? Yes, no.
The first one brings 0, the second one brings 1.
Yes, in this case, I first use the value, I return the value, and then increment by 1 the value of A. In this syntax, I first increment by 1 the value of A, and then use the updated value. Okay? So in this case, I will say I will see 0. In this condition, if I didn't execute this one, I will see 1. Okay?
Ah, sorry.
So this means first returns me the value associated with the key, the label $3 of the current line. After you have returned it to me, increment by 1. Okay? Exclamation mark, very often in many languages, means the negation of this condition. So, returns me x of $3, take the negation, and I use that as the value for my condition. Afterwards, increment it by 1. Okay, so let's see what happens. I first encounter the first line. I take $3. The very first time that I count $3, that is whatever, the value of x $3 is 0 by default. Okay? Because the developers of Oak decided this way. So 0 means false. the negation of 0, which is the negation of false, is true. So the very first time that I encounter this key, this condition is true. And I execute the action. Okay? But afterwards, I increment that value by 1. So the second time that, and from the second time on, that I encounter the same key, the value of x is non-zero, right? The second time will be 1, the third one will be 2. But a number that from 0 means true. The negation is false, so the condition is false. I do not execute the action.
So we don't
So
print.
this is a way to select unique values in Oak in a non-blocking fashion and very effective,
Efficient.
very performant. Okay. This way, if you need to select unique values in a pipe, if you use this trick, it works very, very well, because you don't use sort that is a blocking. This is a non-blocking, because start, first line, takes this value, okay, I produce output, and I keep going. The next time that I encounter the same value, I will do not print anything, and I go on. So the second, or the next command after the pipe can start work as soon as it produces output. Okay?
So you can keep your free parallelization.
Yes, yes,
The parallelization you get for free.
yes,
Mhm.
this is the point.
Okay.
For small files, you don't get any difference.
Yeah.
For big files, that I can assure you that you can have very big files.
Performance differences.
Yes.
Yeah.
Yes.
Thank you so much.
No problem.
Yeah, if you have questions, of course.
Yes.
Yeah.
So you told me that it's implemented with an hash table.
Yes.
So let's say that I'm very unlucky and I have a hash collision. What's going on?
I don't know. I don't think you can have an.
A hash collision.
Yes,
No, because they're, by definition, they're generated in a way that's like the core of the algorithm, that they cannot.
the same string
Right.
gives you the same.
I mean,
index
some
of the
implementations might have weaknesses,
I don't know
indeed.
how
Yeah.
it's implemented in Oak, the actual implementation of the Oak hash
That I
table.
don't know. You should open the source code of Oak.
Good luck. Yeah.
I don't know. I don't know. I'm not aware of hash collisions. Okay.
Yeah, and by the way, just to come back to this, we are good because the thing is, the false of false is true, and after negating all the negations, we kind of lost ourselves. But remember, we were trying to so that's only keeping for the first record, that's like 1, that's 2, that's 0, and we will only get zeros for the multiples of 3s. So that will be false. And we want to remove those multiple of 3 lines. So that's actually fine. That's like what we expect, in the sense that we're only printing the full lines of the other ones. So the 1, 2. So actually, it's all good and logical.
Okay.
Yeah. But it's easy to lose yourself in false of false of false. And yeah. Okay. Unfortunately, I think we are running out of time. I wanted to leave you with one last thing, but maybe we'll just do it after the break fairly quickly. Basically, the exercise was to convert those FASTQ files into FASTA files, and to obtain a FASTA format from a FASTQ format. What we want to do is we want to remove the 4th line of each sequence, so the one that contains the quality score. We also want to remove the 3rd line that's redundant, and it happens so that we want to replace the very first at with basically here, say, this at here has to become like a redirection sign. So, we've learned sed to replace characters with others. So, and we'll use a for loop to do this over all the FASTQ files. So I wanted to do it this morning, but we are just running out of time. And also on that occasion, we'll show a kind of variable reuse that you mentioned. So let's keep this for this afternoon. And once we have, so we already have one bash file, the demo.sh file. So there will be another sh file, converter.sh, we can call it. And then, since we will be very happy with our first bash programs, with our code, we will put them under version control, which lets us not only back them up, but also keep track of all the further modifications. So yeah, let's resume in 1 hour. Thank you so much.